Hi, Trisha. It's Professor Sebastian, and I'm here just to make you a video for your exam 2 feedbacking here in calculus and talk to you a little bit about the final. So let's kind of take care of some nuts and bolts here. When you first turn in your exam, my math lab had you graded at 35.5. So after looking through your work and finding as much credit as I could, I got it up to 49.61, but I know it really just didn't go well for you, which is really disappointing when I see that your first exam you had a 73. We had a kind of a big drop off, and so we need to try to get ourselves, pull up our bootstraps here. You got a week before the final exam. When you get to the final exam is need to prepare this way. 50% of the final exam will come from the first 2 exams, so to cover weeks 1 through 4. So study your first 2 exams really well. Use my feedback videos. Use the help in the in my math lab. Okay, make sure that you understand how to do all the questions on exams 1 and 2. And then the second 50% will come from week 5 and 6. So 25% of the questions will come directly off quiz 5. Okay, so study quiz 5. And then the remaining 25% of the questions will come off of the last 2 homeworks here in week 6 coming up. So that means that 50% of the exam covers the first 4 weeks, 50% covers this last 2 weeks. And there's 30 questions on the exam. I'm giving you a little bit longer. I'm giving you 2.5 hours instead of 2 hours just because we're covering more material. But you get yourself ready, get these homeworks done in week 6 quick as possible and start studying. I think you got plenty of time to ask questions and do well. Okay, so let's kind of pull up our bootstraps and get through this. All right, right now your overall percentage, let me see. Let's look at your overall. Your overall, does it give you your overall? Let me see this way. I know I wanted to show it to you, but I checked that it's set correctly in your, I guess I can't show it like I do. It doesn't give you the average. It does give me your overall average when I look at everybody's. I don't want to show other people's grades, so that's not fair. But if you look at your grade book, it's about a 69.59, so you're sitting at a C minus right now. So we really want to push you up into the solid C's, hopefully even into the B minus or so, or if you can do that with the final exam, which I think you can. Just got to pull this material together, okay? So anyways, that's where we sit and what we need to think about as we're getting ready for the final exam. Let's talk about exam 2. Give you some feedback here. So let's go ahead and review this. Okay, so question 1 you had all right on your own, no problem. Question 2. So first thing that happened is this x plus 2, you made x squared plus 2, which really makes it a lot harder. However, I mean, you were trying to apply the rules correctly, right? Here you were using a quotient rule, but then in the quotient rule, you have to take the derivative of the numerator, which requires a product rule, but you actually started multiplying these out, and then we're going to use the power rule, which that's fine. It's just that it got kind of messy on you. When you have equations like this, and if you can simplify it, so if I multiplied these guys out first and then divide every term by x cubed, this simplifies pretty nicely, right? So I was trying to show you what to do here, but you copied it wrong and it would have been a mess, and I don't even want to go through that. But if you just take this function and simplify it first, so you multiply x plus 2 times x squared minus 2x plus 4, you see a lot of the terms end up canceling. You end up with just x cubed over x cubed, which is 1, plus 8 over x cubed, which is 8 times x to the minus 3. So the derivative, that's really easy. You just apply a power rule, minus 24x to the minus 4. And then the second derivative is also easy. Apply the power rule. Minus 24 times 4 is 90, minus 4 is 96, and then x to the minus 5. So that would have been the much easier and better way to do that than try to use all these long rules. These rules are good when if these are multiplied to powers or something, then yes, that's much helpful. But if you can simplify the function before you take the derivative, then that's what you want to try to do first. All right, question 3. You missed the first 3. It looks like you didn't apply the rule at all, right? This is derivative with respect to x of uv. That requires a product rule. You wrote u prime times v prime. That's not how you take the derivative of a function times a function. It's u first times the derivative of the second plus the derivative of the first times the second. So you have to remember that. And the same thing with the quotient rule. The derivative of u divided by v is not derivative of u divided by derivative of v. You have to use the product rule, right? VU prime minus UV prime over V squared. Low D high minus high D low over low squared. So same here with this, you have to use a quotient rule. So it's like you didn't apply the rules. You just kind of forgot the rules, even though I could tell from up here you knew the rules. So don't forget, you have to apply the rules there. All right. It looks like you didn't answer 4 and 5, and I don't have work for them either. So I added extra pages, which I'll talk about at the end. I'll just go through in the order that you have done things here. So question 7. All right, question 7, this derivative, all right? You want the derivative of 4 cosine x over 1 minus sine x. It looked like you're applying the the quotient rule good. The derivative of 4 cosine x, though, is minus 4 sine x. You forgot the 4. And then the derivative of 1 minus sine x is minus cosine x. You forgot the minus sign. And then the simplification after that would be all messed up without those correct. So just be careful on those. 8 you didn't answer, I'll come back to at the end. 9, 10. 9 you got correct on your own, 10. So 10 is, again, this derivative, so we have to apply the chain rule first. So 2 times the inside to the first power, which you did right here, times the derivative of the inside, which requires a quotient rule. So I just added the proper notation because you actually hadn't taken the derivatives yet. Then you went to take the derivative. So the derivative of minus cosine x is sine x. That's correct. The derivative of 1 plus sine x is actually, the derivative of 1 plus sine x is positive cosine x, right? You have it as negative cosine x for some reason. But so get those squared away and simplify correctly, and you could have the right answer. Okay, so increase your score pretty good there. All right, 11. So it looks like you're starting this derivative correctly. Y prime, you have to use a chain rule, and then the derivative of this. Perfect. Okay, so you end up with 3 times 4 plus 1 over x squared times minus 1 over x squared. That's y prime. Very good. Then you have to go through y double prime, which got all messed up because you didn't simplify things correctly from y prime. So then I walked you through how to do y double prime. I felt like you had the rules down good. It's just that you didn't always apply them correctly, and then in this one you didn't get to the second derivative correctly because you didn't simplify y prime correctly. All right, so then we jumped up here to question 20. And again, I have filled in the blanks at the end here of things that are left blank. So question 20, already correct on my math lab. 21 already correct. 22, you have, so when you're walking through this, your answer is there's at least 1 0. The intermediate value theorem tells you that if I'm negative on one side of my interval and positive on the other side of my interval, if the function is negative on one side and positive on the other side, it doesn't mean there's exactly 1 0. It means there's at least 1 0, right? So I tried to draw this picture for you where you could have a function that's negative on one side, positive on the other side of my interval, but it kind of oscillates around and crosses the x-axis several times in between. So it just tells you at least 1 0, and that's the only thing you got wrong in that question. 23 and 24, you got right on your own. I gave you the benefit of the doubt on 24. Even though it was marked wrong originally, you have this as 9 to the 9th. I'm pretty sure you meant x to the 9th, so I just marked it completely correct. 25 you didn't answer, I'll come back to. 26. So for 26, you have a function on a half-open interval, right? It's open from up to negative infinity all the way, but then it's closed at 1 on the right. So when you find its critical points, you find that x equals minus 5/4, which is certainly between minus infinity and 1, is a critical point. Okay, so you check the critical points, right? Like you were doing, and then you notice that, well, as x goes off to infinity, the easier way to do this would be to actually do the first derivative test here, right? So when you do the first derivative test, you could see that the graph would look like this. So you can see that there is no absolute minimum. There's a local minimum here. There's a local maximum here, which is also the absolute max. Okay, so you can see how to answer those questions correctly. 27 you didn't answer, I'll come back to. 28 you got correct on your own through my math lab. 29. Let's see, I believe it was 29. So you got, now you jumped around a little bit on your work. So let's see, 29. I went over later, and why did I mark it right? So it must have been right on your own already. Yeah, 29 was right on your own already. Okay. All right, so now back to, let's fill in those gaps here. So of where you didn't have work or there was work I missed towards the end. So question 6. Okay, so these are wrong. However, you actually were doing some things correctly, right? So if you want the average cost per appliance, you do need C of 150. That's how many it takes to produce 150 appliances, but then you need to divide that by 150 to get the average cost of making all 150. So that comes out to be $60.33. And then for the marginal cost of when 150 appliances are produced, that means what's the marginal cost of producing one more appliance? So that comes out to be 40. And you're basically estimating that by using the derivative. And then in part C, it says, well, what is the actual cost of producing one more appliance? So that would be C of 151 minus C of 150. Okay, so I did increase your score here from 0 to 0.67 because it looked like you were doing the right things here. You didn't know how to do this last part. Okay, question 12. You had some work on. So these last 4 pieces were not correct. So I actually will do this on the added page 5, and I'll show you how to do that. Okay, so I'll go back to that in a second. 16. You had some work here. So you have to assume that x and y are both implicit functions of time. So when you're taking their derivatives, like the derivative of x squared would be 2x, but then you don't know what x is, so times dx dt. It's a chain rule, right? So 2x dx dt plus 6y dy dt plus 4 dy dt equals 0. Then you want to solve this for dy dt because you're given what dx dt is, what x is, and what y is to figure out what dy dt is. Solve it for dy dt, plug in the correct values, and you get 5. So it looked like you kind of knew you needed to take the derivative here, but you kind of got off on not sure that x and y were functions of time and how to do that implicit differentiation. All right, 17. We want to basically just take the derivative because, right, dy is f prime of x dx. So we need the derivative of this guy. So we have to use a product rule. So it'd be, you did look here, it's like you tried to almost take kind of the derivative of each multiplied times each other, but you're forgetting all of a sudden you need the product rule, right? So first times the derivative of the second plus the second times the derivative of the first. That's what I have here, and then I would let you finish that at this point. But again, I thought you knew the product rule. It's just it just went out of your mind when you got to the problem. Okay, now all your problems that were unattempted. All right, now I'm going to run out of time here because I can only do 15-minute videos here. So I'm going to stop and start another video for you. Be back in a second.